Hi, everyone. I'm Jeff DeMoss from Red Hat AI Product Management. Welcome to the Q2 edition of our What's New, What's Next update. In this session, I'm going to be joined by my colleague Tushar Katarki, also in Red Hat AI Product Management. We're going to give an overview of recently released features and cover the Red Hat AI roadmap for the second half of the year. For the Red Hatters joining us, you can post your questions in the Slack channel listed on this slide. We should have some folks monitoring that channel throughout the session. We host these What's New, What's Next sessions quarterly, and you can find the recording and these slides after the session at the link on the screen. And then finally, as a reminder, this is a roadmap session, so forward-looking statements are subject to change. And with that, let's go ahead and get started. So before we get into some product details, I want to start out by resetting what we're seeing in the market and what we're hearing from customers. We see a growing number of customers moving from pilots and POCs to production deployments, but there are a few things many organizations are struggling with. First, many enterprises are struggling with the high cost of frontier AI services, especially as they expand their use cases and move to production to run at scale. Next, they struggle with the complexity of integrating their private enterprise data with models and achieving the accuracy and consistency they need. And many also need greater control and flexibility over where they deploy their use cases due to compliance, data privacy, or sovereign AI requirements. The bottom line is that to move AI into true widespread enterprise production, customers need more options with cost-efficient models, aligned to the use cases they care about, and the freedom to run their AI anywhere. So these are some of the challenges that we're aiming to solve with the Red Hat AI platform. Last year, we introduced 4 pillars of our AI strategy. First is fast, flexible, and efficient inference. Now, last year, we invested significantly here, particularly with the Neural Magic acquisition. We're going to continue that focus this year, as inference is where many customers begin. Next is connecting models to enterprise data for domain-specific accuracy and customization. We're expanding our approach here with a set of capabilities for prompt management, RAG, and fine-tuning. Next is accelerating agentic AI deployments. There's obviously a lot of excitement around agents as the next evolution of applications, and we're ramping up our investment here, adding new capabilities in this rapidly evolving space. And then the final pillar is the platform foundation that enables organizations to scale AI across the hybrid cloud. It includes capabilities like observability and safety, and enables use cases like model as a service and GPU as a service. So we're going to dive deeper into each of these pillars and discuss some product plans in each area. Okay, Red Hat AI is our portfolio of enterprise AI products and includes Red Hat AI Enterprise, Red Hat AI Inference, OpenShift AI, and RHEL AI. Red Hat AI Enterprise and Red Hat AI Inference are both new this year. The platform is designed to support the full AI lifecycle for both Gen AI and predictive AI use cases for enterprise customers. All Red Hat AI products support hybrid environments. So whether that's public clouds, on-prem, or at the edge, as well as a variety of accelerators, including NVIDIA, AMD, Intel, and more. So ultimately, our goal is to enable any agent, any model, any accelerator, and any cloud. Red Hat AI Enterprise is our flagship integrated platform. It combines OpenShift AI and OpenShift into a single solution for building, tuning, and deploying both Gen AI and predictive AI. At the top layer, we provide tools for AI application and agent development, including model catalogs and an AI gateway for secure access to models and assets. It's supported by an inference at scale layer that handles the heavy lifting of serving models efficiently. The platform also includes the security, governance, and observability capabilities needed for production. And then underpinning everything are the container and Kubernetes platform services, which manage resources across a range of hardware accelerators and infrastructure. So this architecture ensures operational consistency, whether organizations are deploying in a private cloud, a sovereign cloud, or at the edge. Okay, with that, I'm going to turn it over to Tushar.
Thanks, Jeff. Hi, everyone. Again, we'll talk next about fast, flexible, and efficient inference and the technical innovations that we are making in this pillar for efficient inference across the hybrid cloud. Next slide, please. Uh, this is a holistic reference architecture for deploying and scaling language models in the enterprise. This diagram shows the full stack from accelerators at the bottom through the inference server and distributed inference layer up to the model gateway and API management at the top. The key message here is that this is not just VLLM on a single GPU. It's an integrated platform that covers model optimization, distributed serving, multi-tenant governance, and external provider egress, all that are Kubernetes native. It runs on OpenShift or RHEL or with third-party Kubernetes and Linux, with support for both NVIDIA, AMD, and many other AI accelerators. It's designed so that models, infrastructure, and governance are all managed as custom resources, definitions, and declarative, GitOps friendly, and are auditable. And this stack is available on Red Hat AI Enterprise, Red Hat OpenShift AI, and Red Hat AI Inference that Jeff talked about earlier. And therefore, you can have a turnkey solution that you can make you into a cost-effective token provider for your organization instead of just being a token consumer. Next slide, please. VLLM is the inference engine at the heart of everything we do, with nearly 80,000 GitHub stars and over 2,000 contributors. VLLM has emerged as one of the fastest growing AI infrastructure projects in the open source, with best-in-class inference performance and hardware portability across NVIDIA, AMD, Intel, and more. What's new in the first half of 2026 is significant. We have full NVIDIA Blackwell support for B300 and GB300 with an optimized stack. On the AMD side, similarly, MI325X with major improvements to ROCm. The performance numbers speak for themselves. A 38% throughput improvement on Blackwell with GPT OSS 120B and 40% inter-token latency reduction for DeepSeek v3.1 on H200 and 3 times speed up for Whisper audio transcription. These are just some significant numbers that we are talking about. We have many more benchmarks. Async scheduling alone gives you roughly 10% throughput across the board. Speculators that we show here are small, fast draft models to propose multiple tokens, which the larger model verifies in a single forward pass. This can decrease time to first token significantly. VLLM has native support for speculators, and a library of speculator models will be used with the target large models to improve performance without any special heavy lifting on users' behalf. Also, the much asked for CPU inference with VLLM will be available is already available for Intel AMX and AMD EPYC. Look ahead to the second half. Looking ahead at the second half, there is day zero NVIDIA Vera Rubin support and day zero support for new models that will be coming out. VLLM Omni for unified multimodality, any modality in, any modality out. And work is underway upstream for support for diffusion models, which, unlike autoregressive models, can do token generation in parallel and therefore can achieve significantly better performance and achieve effectiveness. Next slide, please. This is about going from a model on Hugging Face to a validated, optimized model running in production quickly and safely. We take third-party open-weight models, validate them, apply quantization and compression using LLM compressor, train speculators for speculative decoding that I talked about on the last slide, and publish them to our model catalog. Why this matters? It's time to value for you all. Instead of your team spending weeks figuring out quantization schemes and benchmarking or trying to containerize them into model cards, we have already done all that for you. And it reduces GPU costs. An FP8 or NVP An NVIDIA FP4 model uses a fraction of the memory and runs faster on modern hardware. Furthermore, we have containerized these models into model cards, like I mentioned, included metadata about performance and optimal configurations, and they are available via an awesome user experience on Red Hat AI model catalog in the console, in the product console. So what's new? The catalog now covers the latest across every category: coding with Qwen3 Coder, for example, reasoning with Phi4, a multimodal um, uh, with uh, uh, with Qwen 3 VL at 235B, large frontier models like Mistral 675B, and efficient edge size models like Nemotron Nano, and we'll continue to add more. There are more than 650 validated and optimized models in the catalog last time I looked. Coming next, tool calling validation. We'll be validating an initial set of models for tool calling scenarios on Red Hat AI. We'll also be supplying the files and commands to run them from the catalog. Similarly, we're going to do more on supply chain integrity for models, adversarial robustness and safety testing, and securing the runtime, all critical for regulated industries and enterprises. Next slide, please. Red Hat AI has an awesome performance engineering team, and it regularly participates in MLPerf benchmarking testing. So this is MLPerf Inference v6.0, the industry standard benchmark across VLLM, Qwen 3 VL, Whisper, and GPT OSS 120B. ML performance benchmarking is like spec benchmarks for enterprise apps that many of you might be familiar with. Furthermore, these MLPerf results directly translate to optimized inference configurations that you can use in production. That's what this flowchart is trying to show you. The workflow here is we run the benchmarks, the results go into our performance databases, then become part of Red Hat AI optimized configurations and performance data, and those configurations are what we ship with our validated model catalog. So when you deploy a model from our catalog, you are getting the benefit of all that benchmarking work, the right quantization, the right batch setting, the right hardware config out of the box. Next slide, please. LLMD is where we move from a single instance VLLM to production-grade distributed inference. It's Kubernetes native, built on Envoy and VLLM, and it delivers predictable and user-configurable latency and throughput at lower cost per token through two key innovations: disaggregated prefill and decode, and inference-aware routing, or what is also known as prefix-aware routing, which means that routing requests to the VLM instance that already has the relevant KV cache loaded. It also allows ability to increase throughput with KV cache offload and management and large models that may not fit into one GPU memory with wide expert parallelism. So what's new in the first half? Distributed inference with LLMD is now available on cloud-native Kubernetes services, and we'll talk more about that. With inference-aware auto-scaling, we're going beyond just pod metrics for scaling and focus on saturation-aware intelligence. By monitoring the KV cache usage and request shape, we ensure that you have exactly the right amount of GPU capacity at any given time, preventing both performance bottlenecks and wasted spend on idle hardware. OpenAI batch inference support lets you submit large number of requests asynchronously for offline processing at lower costs and higher throughput instead of serving each request interactively in real time. Ability to prioritize traffic to most critical workloads with request prioritization routing is coming in the second half. In addition, we are doing a number of incremental but important improvements like zero trust internal security, a guide for setting up Rocky focused on LLMD and connecting LLMD to inference gateway that enables private by default connectivity model. The second half roadmap also looks very interesting. We are introducing distributed KV cache offload to a hierarchy of storage tiers, including to CPU, multi-cluster inference routing, LoRa support for efficient multi-model serving, and other operational improvements. Next slide, please. Model gateway is the multi-tenant governance layer for LLM serving. Think of it as the enterprise control plane that sits between your users and your inference infrastructure. It provides token-based quotas, tenant authentication, usage tracking, and audit trails. All the things a regulated enterprise need before they can let themselves do a self-service AI. So what's new in the first half 2026? Model Gateway is GA for production use. It allows mass platform admins to do automated key lifecycle management via an intuitive user experience in the OpenShift AI console. It provides admins to configure token-based rate limiting. The mass admin UI allows for setting up users, groups, and tier management and showback usage tracking dashboard. We also support external OIDC providers, which I know many of you enterprises will have, and ability to connect to external model providers while enabling the same ability of control and governance that you find for your internal models that you are hosting also. So what's next in second half 2026? A GA of egress to external model providers, multi-model intelligent routing, and then multi-cluster failover mechanisms bursting for additional capacity. Next slide, please. The AI gateway is the next evolution of the model gateway. It is a centralized control plane that manages and governs all AI and agent traffic, not just calls to language models, but also tool calls, agent-to-agent communication, all of it. The AI gateway integrates the model gateway for LLM serving that we talked about on the previous slide, an MCP gateway for tool access, agent-to-agent calls, and also includes safety and guardrails, all behind centralized auth, role-based access control, cost routing, and semantic routing. It sits between your developers, agentic workflows at the top, and your self-hosted GPU infrastructure run by Red Hat AI and external provider APIs at the bottom. Why does this matter? Today, most enterprises have fragmented model access, duplicated agent infrastructure, and inconsistent guardrails. The gateway replaces all of that with centralized policy enforcement, intelligent routing, shared memory, and end-to-end observability. First half of 2026 delivers auth, RBAC, model gateway, MCP gateway, and safety and guardrails. Second half adds cost routing, semantic routing, and inference time scheduling integration. We'll talk about that a little later. With that, I want to talk about one last slide in this section, which is all about, when you move past the hello world of LLM deployment and start running models at scale. This is a case study from a big car maker's production environment. It's a public blog that they have written, so you go take a look. But this is all built on Kubernetes with LLMD and Kubernetes at the core. The initial approach was straightforward in this case, VLLM in a Kubernetes stateful set. But three problems were hit fast. Model weights are hundreds of gigabytes, so network storage was too slow. Switching to local storage created rigid node affinity. And then one hardware failure, you're doing manual recovery in that case. And round-robin load balancing completely ignores the KV cache on the GPU, which is the key to VLLM's throughput, by essentially wasting expensive GPU cycles. This is something that we talked about earlier when we talked about LLMD. The solution was the K-serve plus LLMD plus VLLM stack. The game changer here is the prefix cache-aware routing through the Envoy AI gateway. Instead of randomly assigning requests, it routes each request to the VLLM instance that already has the relevant KV cache blocks loaded. This is all Kubernetes native with standard gateway API, LLM inference, service CRDs. There are no new abstractions to learn. The results speak for themselves. Look at the chart. That inflection point at 12:30, which is something that I've highlighted there in the red, is when the routing change went live. Output tokens per second jumped by 3 times. Time to first token dropped by half. Same hardware, same model, LLM Llama 3.1 70B on 4 AMD MI300X GPUs. The only thing that was changing was the smarter routing. And because all of this is open source, production issues that this enterprise were solved, using this combination of Kser, LLMD, and VLLM. With that, I'll hand it back to Jeff for agent.
Okay, very good. So next, let's take a look at how we're accelerating agentic AI deployments. So starting out, this diagram shows how we're operationalizing agentic workflows in Red Hat AI. Starting at the top, we recognize that AI engineers and developers use a wide variety of tools and frameworks to build agents. A key differentiator for us is that Red Hat AI is framework agnostic. So we provide the environment to run agents regardless of how they were built, from LangChain to Crew AI or custom Python code. So moving down, the API layer provides the standardized entry point to the core agent components. Through our AI gateway, we manage access to models, whether they're self-hosted via our VLLM and LLMD framework, or external APIs like Gemini and GPT. Now, agents need to actually do things, which typically requires data and tools. We enable models to connect to RAG databases and enable secure connections to external tools through MCP and our MCP gateway. To ensure enterprise trust, we've integrated NEMO guardrails for real-time safety, and we added support for automated red teaming via Garrick. Finally, we're working on enabling secure agent-to-agent communication APIs for multi-agent workflows. The entire agent lifecycle is managed through an agent ops framework, giving engineers capabilities like tracing, evaluation, and security needed to deliver these agentic services at an enterprise scale. So to help support a framework agnostic approach, we're providing a standardized API layer for agentic workflows. Now, the key here is that these APIs are OpenAI compatible. So developers get a familiar experience out of the box, but with the flexibility to run the entire stack on-prem in a sovereign environment. So looking at what's new for the first half of this year, we're offering the Responses API as a tech preview. So this is the foundation for standardizing how agents interact with models and handle multi-step tasks. We've also added OpenAI compatible annotations, allowing applications to display source documents and citations using a standard format without rewriting code. Additionally, we've expanded support for vector store providers like Quadrant and pgvector. Looking ahead to the second half of this year, we'll move the Responses API to GA and mature the Conversations API. We're also planning to introduce the Messages and Interactions APIs to provide the front-end protocol support needed for agents originally written for Anthropic or Google. Finally, we're adding Anthropic and Gemini as remote providers and enabling multi-turn tool calling to support more complex autonomous workflows. So as I mentioned earlier, agents require access to data and tools to be effective. MCP, or Model Context Protocol, provides a universal standard for connecting models to enterprise tools. With the MCP ecosystem on OpenShift AI, we're taking a platform approach to how you discover, deploy, secure, and govern MCP servers at scale. So looking at what was new for the first half of this year, so we introduced the MCP gateway as a tech preview. Now, this is really the control plane that provides a centralized point for authentication, auditing, and governing how agents interact with MCP servers. We also launched the MCP catalog as a developer preview for discovering MCP servers from Red Hat and partners. To make it easier to get started, we've integrated a lifecycle operator so you can deploy these MCP servers directly from the catalog. Then once they're deployed, they're registered with the gateway and available for use within GenAI Studio. Looking ahead to the second half of this year, so we'll continue maturing these capabilities by bringing the gateway, catalog, and operator to GA. We'll also introduce an MCP registry for managing the complete lifecycle of MCP servers. And then finally, we'll be adding an ingestion pipeline to provide a standard enterprise-ready process for adding new MCP servers. All right, so now let's look at agent ops. This is how we bridge the gap between experimental AI and production agents. It's a unified approach for managing the full lifecycle, security, and performance of agents and their tools. And there are roughly 3 pillars. So first is observe, trace, evaluate. We're using MLflow to log full execution traces, including tool calls. This is OpenTelemetry compatible, so it plugs into existing observability stacks. For evaluation, we're combining Eval Hub and MLflow for dataset curation and scoring to ensure agents are working as intended before they go live. Second pillar is identity and access control. Agents are autonomous actors, so they need their own identity. We're integrating Spiffy and Spire to provide trusted workload identities, combined with OAuth 2 token exchange for secure delegation. This ensures that when an agent acts on behalf of a user, it only has the specific permissions needed for that task. The MCP gateway then governs that access, ensuring agents only reach the tools that are authorized to use. The third pillar is develop and deploy reliably. So this covers agent lifecycle management and connects agents with identity and policies. It also incorporates agent safety using guardrails and red teaming tools like Nemo and Garrick. So the bottom line is that we're providing enterprises the operational rigor to move agents from experimentation to production without locking them into any single framework. So building on the pillars from the previous slide, here's an overview of the timeline for our agent ops delivery. So for the first half of this year, we introduced agent deployment and lifecycle management alongside automatic MLflow tracing as preview features. So these work together to create a deploy and observe experience where tracing is injected automatically. Tracing is an observability feature that records every step in the path of a multi-step agent to help with debugging and optimizing agents. We also are integrating Spiffy and Spire for trusted agent identity, which is key to providing secure access to tools. We also added an evaluation hub, which we'll cover a bit more in a later slide for evaluating agent performance and safety. Then looking ahead to the second half timeframe, we'll move those deployment and tracing capabilities to GA. We're also planning to introduce sandboxed execution environments to ensure that agents can run code safely in isolation. Finally, we'll launch the agent catalog and registry, which will serve as the central system of record for governing and auditing all agent assets across the enterprise. Okay, in the previous slide, I mentioned sandboxed execution as a second half priority. OpenShell is a great example of the upstream work that we're doing to explore that concept. OpenShell is an open source collaboration between Red Hat and NVIDIA that looks at securing agents at the operating system level rather than just through code. So the idea is to create a containment layer where real credentials never reach the agent process and network access is restricted to approved destinations. So even if an agent is compromised, there's nothing to steal and nowhere for it to go. It's framework agnostic, meaning it can protect any agent without requiring code changes. So while this is currently an upstream project, it's an example of how we're researching the technologies that will eventually drive our production sandboxing and safety capabilities. All right, so finally is GenAI Studio. We introduced a preview of GenAI Studio in OpenShift AI 3.0 last year, and we're significantly enhancing it throughout this year. GenAI Studio provides an interactive playground for AI engineers to easily experiment with models, tools, and the associated components needed to develop agents. The goal is to surface the agent components that I showed in the previous slide in a single interface to accelerate the development process. So for the first half of this year, we added prompt engineering and management. We are in the process of incorporating the key capabilities of the Watson XAI Prompt Lab feature and the MLflow prompt registry for a complete prompt engineering and management solution. We also added model and configuration comparison. So this enables side-by-side comparisons of not only models, but complete configurations, including prompts, data, and tools. We also added an integration with MCP Catalog, which I mentioned before is a dev preview feature. So MCP servers deployed through the catalog are available for discovery and use in GenAI Studio. And then finally, vector stores are also now surfaced directly in the interface. For the second half timeframe, we'll add guardrails integration to enable safety policies during testing and session tracing to help with debugging. We're also looking to add multimodal support and the ability to deploy configurations as agents. All right, with that, I'm going to pass it back over to Tushar.
Thanks, Jeff. Now let's look at how we are making it easier to connect your models from your private enterprise data to your models through prompting, RAG, and fine-tuning. Next slide. Yeah, we have added a number of new features in this pillar in the 3.4 release for the first half 2026. Most users begin their GenAI journey with prompting by uploading data in the prompt window along with your prompt. You saw some of that, in Jeff's GenAI Studio on a couple of slides ago, right? So what we are doing new here is to introduce a new prompt registry and prompt tuning capabilities in Red Hat AI, taking it a bit further and making it easier to build such applications on your own in case you have a use case to provide a RAG-based chatbot capabilities. As part of a RAG pipeline, we aim to make it easier for you to get started with building the RAG pipeline with a new auto RAG feature, which we'll talk about. Then finally, the success of any app, GenAI especially, is defined with evaluations. In fact, evaluations should be the first piece that is defined. You need to know how to measure what you're building. Evaluation Hub is our newest module, which will allow to run evaluations for your models, whether that's for fine-tuning, RAG, or agent evals. We'll talk about that also coming soon. Next slide, please. RAG still powers a lot of GenAI use cases in production. RAG is powerful, but notoriously complex to optimize, as some of you might recognize that. Our auto RAG capability aims to automate that process and get you started quickly. Instead of manually guessing the best chunk size or embedding model, auto RAG runs automated pipelines to test multiple algorithms and techniques for your specific dataset. It performs hyperparameter optimization across variables like vector stores and top K retrieval settings, and then evaluate the results using advanced metrics like faithfulness and answer correctness. This shifts the work from tedious manual testing to automated optimization, allowing your teams to move from a raw data set to a high-performing RAG pipeline in minutes instead of days. We are targeting a tech preview of this end-to-end UI and a notebook experience of auto RAG pipelines in 3.4. That's already happened. In the roadmap, we're looking at evaluations at each step of a RAG pipeline and advanced context intelligence features like agentic RAG, graph RAG, and multimodal RAG, and more. Next slide, please. As Jeff alluded to at the start, Red AI is not only a Gen AI platform, but also a predictive AI platform. And not every AI use case requires a language model. Enterprises still have a massive number of predictive intelligence workloads, customer churn, fraud detection, demand forecasting, using regression analysis, for example, risk scoring. These are classical ML techniques, and they deliver faster, cheaper, and more explainable results. The challenge has always been the complexity of these. Building a production-grade ML pipeline requires feature engineering, expertise, hyperparameter tuning, model selection, and rigorous validation. That work is slow and requires specialized skills most teams may not have in abundance. with Auto ML in Red Hat AI, powered by Auto Gluon. We're automating this entire workflow. You bring your data set, define your prediction target, and the platform takes it from there using AutoML. It runs multiple algorithms across a range of hyperparameter configurations, evaluating them against metrics like F1 score, ROC curve, and a confusion matrix, and surfacing a ranked leaderboard of the best models for your specific use case. The result is that data scientists spend their time on problems that matter, understanding their data and their business, rather than on the glue code of building pipelines. This continues to build on our vision of an unified experience where whether you are fine-tuning an LLM or building a predictive model, Red Hat AI guides you to the best outcome with the least amount of friction, faster to market, easier to operate, hopefully no machine learning PhD required. Next slide, please. AI is no longer experimental, as many of you know this, right? Teams are building models, rack pipelines, agents, and full applications and moving fast. But the truth is, most teams are flying blind in the sense that the dominant approach is still demo-driven development. Iterate until it looks good, ship when stakeholders nod. There is a better way. We think this is the evaluation driven development, EDD. Define your success criteria before you write a single prompt. Eval Hub is a comprehensive evaluation platform for AI systems. Now in the first half of 2026, the capability focus on evaluating models, RAG systems, agents, and full applications using popular or custom frameworks. We benchmark both performance and safety, assessing models and guardrails against risk criteria. So that's basically what Eval Hub is bringing. We assess capabilities like autonomy, tool execution, and reasoning quality, and we provide industry-specific test suites for healthcare, finance, and more, ready to use out of the box. So looking forward to second half of 2026. Automatic evaluation generation for your production LLM traces, something that Jeff mentioned earlier, which is automatically included through our agent framework. Segmented analysis that gives you actionable recommendations like which guardrail to adjust or which model to switch to, and reference notebooks for visualization. How to use it? There are three ways to access Eval Hub. There's a REST API with full docs at the URL that is shown there. You can follow that. A Python SDK that you can do, which is a part of our Python index. You can pip install inside Jupyter Notebooks, or the Red Hat AI evaluation UI for a no-code web interface. Next slide, please. You'll see a picture of that here in the slide. Okay, inference time scaling. Retraining, be it pre-training or post-training, isn't always the answer to better accuracy. Inference time scaling, or also known as test time scaling or test time compute, is a new technique that allows models to think more at runtime rather than during training. By reallocating compute power to the answer phase, we can use parallel search to generate multiple candidate answers and the reward model that selects the best one. This is it can be a game changer for high-stake fields like finance or healthcare, where accuracy is more valuable than just raw speed. It allows smaller, more cost-effective models to achieve performance levels previously reserved for massive frontier models, all while using your existing infrastructure. So what's new in the first half of 2026, which is basically 3.4? Inference time scaling SDK is available in our Python index, and the inference time scaling gateway integration is already integrated upstream in our model gateway. So what's next? The integration into Red Hat AI Gateway that I spoke about earlier. Algorithm parity, same options in SDK and the gateway, and then integration across products, including synthetic data generation, evals, and model as a service. Those are some of the integrations that you can expect to come to see. Jeff, I'm going to hand it back to you for AI platform.
All right, thanks, Tushar. All right, so let's take a look at platform capabilities that enable scaling AI in production. So first, observability is a focus area for us this year. Our goal is to deliver native experiences that provide deep visibility into the health, performance, and behavior of the entire AI stack. So looking at the first half timeframe, we delivered first a unified metrics backend that's built on OpenTelemetry and the cluster observability operator, also utilizing Prometheus and Tempo. This establishes the central foundation for capturing and storing metrics across all AI workloads consistently. Next, we introduced foundational Perseus dashboards as a tech preview feature. These include a cluster admin view with metrics like deployed model count and GPU utilization, and a models view with metrics like time to first token and end-to-end latency. We also introduced, as part of our model as a service feature, an admin showback dashboard as a tech preview feature with consumption and usage tracking metrics to facilitate cost management. For the second half timeframe, we'll mature the mass showback dashboard to GA and add native observability for GPU as a service and LLMD metrics, as well as automated drift detection to monitor model accuracy over time. So next is AI safety. Safety concerns are a primary blocker preventing AI pilots from moving into production. We view AI safety as a proactive framework to detect and mitigate risks throughout the entire lifecycle. For the first half timeframe, we significantly expanded the baseline AI safety capabilities that were based on Trusty AI. First is red teaming. We integrated the Garrick open source project with technology from our Chatterbox Labs acquisition. This enables automated adversarial attacks to uncover vulnerabilities like jailbreaks and injections during the testing phase. Next, we enhanced existing guardrails capabilities by adding NEMO guardrails to enable filtering of inputs and outputs at the inference layer. These protections will also extend to the AI gateway, covering both models and MCP servers. Looking ahead to the second half of this year, we'll add risk assessment capabilities by surfacing Chatterbox-powered safety data directly in the model catalog to help teams assess risks during model selection. We'll also mature AI Gateway guardrails to GA and surface guardrails natively in GenAI Studio. Finally, we're looking to introduce an AI safety advisor to help translate enterprise policies into specific red teaming and guardrail configurations. Okay, in the agent ops section, I mentioned MLflow for agent observability and tracing capabilities. We're including it in this section too because it impacts a broad set of capabilities across the platform. Now, MLflow has been a leader in the open source MLOps space for years. And with the release of MLflow 3, the project was essentially reimagined for the GenAI era. So overall, it's a unified system for tracking, evaluating, and managing the end-to-end lifecycle for GenAI models, agents, and predictive ML models. In the OpenShift AI 3.4 release, which was in May, MLflow is now GA. So this enables one, direct UI access from the OpenShift AI dashboard and inclusion of the SDK in all Workbench images. It provides unified experiment tracking across predictive AI and Gen AI. It also provides a prompt registry for versioning and managing prompts and integration with Gen AI Studio, like I talked about earlier. It also enables agent tracing, as we covered in the agent ops section. So looking ahead to the second half of this year, we'll introduce an integration with Eval Hub, which Tushar talked about, to enable the automatic evaluation of agent performance and reasoning based on their MLflow execution traces. We'll also add integrations between MLflow and other OpenShift AI components like AI pipelines and distributed workloads. Okay, so this slide provides a high-level view of the major features and enhancements being delivered throughout this year. We covered many of these details in the previous sections, But the key takeaway here is the scale of investment being made across all 4 pillars. So these new capabilities are designed to move AI from experimental pilots into a consistent, safe, and observable environment at scale. All right, so here's a look at our Red Hat AI release cadence and support life cycles. We're delivering GA releases once a quarter with 7 months of support alongside monthly early access releases to get new features to early access customers faster. These early access releases are not supported and they're not intended for production. Now, for organizations that prioritize longer-term stability, we provide 1 EUS release a year with an 18-month support window. All right, so this slide summarizes what we've covered for Red Hat AI Inference from 3.3 to the 3.4 release in May, and our high-level priorities for the second half of the year. I'm not going to go into the details here. This is really intended as a reference. And then similarly, this slide summarizes what we covered for OpenShift AI, again, from 3.3 to the 3.4 release in May, and the priorities for the second half of this year. Again, I'm not going to go into the details here as it's really intended as a reference slide. So with that, I'm going to pass it back over to Tushar.
All right, thanks, Jeff. This is the last section. We'll mostly talk about go-to-market, and next slide, please, and what we announced at Red Hat Summit. The first thing you'll notice here is this slide introduces Red Hat AI Inference as a standalone composable product and not just a feature of Red Hat OpenShift AI. So although it's included in Red Hat OpenShift AI, this allows you to consume it as a separate product. The key message here is VLLM on any Linux. LLMD with VLLM is now available on CoreWeave and Azure Kubernetes services, with early access on additional managed Kubernetes platforms also available. This matters because not every customer runs OpenShift as much as we would want them to. So if they are running on, for example, AKS or CoreWeave or other Kubernetes distribution, you can still take advantage of the Red Hat AI inference stack, the model catalog, the LLM compressor, the optimization that we do, Kser for orchestration, the network and security policies, all that without requiring full Red Hat OpenShift AI deployment. You can integrate with third-party AI gateways today and leverage our mask capabilities in the second half of 2026. The architecture is composable, and so you can pick the layers you need and integrate with what you already have. Next slide, please. The other one is the Red Hat AI Factory with NVIDIA, is a full-stack reference architecture and solution for enterprises going all in on AI. It spans the entire life cycle from data prep and customization through development and deployment on NVIDIA hardware. This is something that we first announced back in the first quarter of this year. We reiterated that in the second half, and we added day zero support for basically the Blackwell series now, and we'll basically bring day zero support to enable Vera Rubin across our portfolio, increasing Red Hat AI in the second half. Basically, you have NVIDIA server and rack scale platforms like DGX, HGX, RTX Pro, Spectrum-X, Bluefield, and Blackwell available now, and day zero Vera Rubin support in the second half of 2026, something that I said. Red Hat, on top of that, we have Red Hat AI Enterprise and NVIDIA AI Enterprise together providing virtualization, container abstraction, container orchestration, MLOps, high-performance networking, and confidential compute. This is the validated end-to-end solution from Red Hat and NVIDIA. It's tested, certified, reference architecture and solution that covers predictive machine learning, generative AI, and agentic AI with optimized models, quick starts from Red Hat and NVIDIA AI blueprints all included. Next slide, please. IBM Fusion for Red Hat AI is the turnkey on-prem answer for organizations that need data sovereignty. It closes the gap between AI pilot and production for environments where data cannot leave the premises. This is something that we announced at Red Hat Summit, and it's now generally available. The three key differentiators here are it's pre-validated and operational in days, not months. The solution, it's a full stack a solution from hardware to the AI lifecycle, and it's built for three teams: the IT ops team who manage it as a single unit, AI developers who get self-service access to GPUs and validated stacks, and data engineers who get content-aware pipelines that make data, RAG ready, for example, or available for agent context, etc. The positioning is very clear. This is not a complex integration project, it provides sovereignty, it provides privacy. It's the infrastructure stack collapsed into one validated day one ready platform for your use, immediate use. Next slide, please. The other exciting thing we announced at Red Hat Summit and now generally available is the Red Hat AI Inference on IBM Cloud. This is a fully managed AI inference service powered by Red Hat AI for organizations that want production-grade inference track without having to manage the inference infrastructure. The four key value props are deploy, scale, and govern agentic workloads on a managed service, enterprise-grade reliability and security, SLA-backed model execution, and hybrid portability without vendor lock-in. You can take advantage of IBM Cloud here and also use the OpenShift AI and Red Hat AI available on any infrastructure for on-prem use cases. Next slide, please. So in summary, as Jeff and I talked about, with Red Hat AI, we are trying to bring you a complete generative AI and Red Hat AI, predictive AI platform, which has four key pillars. The first one really is the inference pillar, the agents pillar, and the data pillar built on the platform pillar. So you can confidently run any model or any agent on any infrastructure. Next slide, please. Finally, this is a set of references that we have covered, including our technical blogs and demos. If you want to see them in action, if you want to try the products, we do have a 60-day trial period. So that's the barcode for that. That's it for this session. We'll see you again, hopefully next quarter when we do